Here we'll look at extending European strengths with embedded AI. So we'll now dive into AI in industrial context with Nico Kelling, head of the Center of Excellence for Infineon. And a third announcement, because we'll also have a workshop by one of our partners, Nodo will talk about how to implement data mesh architecture using data virtualization right over here, if you look over the room. Exactly. The people who are leaving now. Otherwise, I'd slowly welcome Nico Kelling onto the stage. Exactly. Nico has been working at Infineon for 25 years now, if I calculated correctly. Since 2019, he's been the head of the Center of Excellence for AI, and he's particularly concerned with shaping the digital transformation and innovation, especially value-oriented AI in line with the European understanding for society and people. So, Nico, very happy that you're here, and the floor is yours.
Thank you very much. Good morning all together. It's a pleasure to be here today. I want to draw the attention maybe to a slightly different area that we haven't talked so much yet in this context here, really bringing the AI into the production, creating value in the applications, and how to make this happen together, combining this with the values that we have in our society and the urgent needs that we have to also address, thinking about sustainability and environmental friendliness and efficiency. So we have heard yesterday already that the penetration rate or the adoption rate of AI is still rather low overall. We heard numbers between 10 and 30%. I hope that some of the aspects that I will touch here afterwards will maybe give some thought for some further adoption. So I will start with a simple statement here. Probably well known, the amount of data is growing dramatically already today, but it's going exponential up. The interesting thing is that quite a good share of that will require processing of this data in real time. And if we look at this, we cannot do this all centrally anymore. Quite an amount of this data is being generated decentrally, locally at some sensors, at some devices, at some equipment. And we have to find ways how to process this data, how to get some insight from this data to generate meaningful insight and decisions for our systems. Clicker doesn't work. So what this means is that we will see a transition over the coming years. It's already in full swing, the transition from mostly cloud-based systems to edge or embedded, what I call the embedded AI kind of systems. And of course, it's not a replacement, it's a continuation, it's an extension, and the overall thing will be a continuum. But we have to see where's the optimum between processing at the cloud and processing close to the real world where it actually happens. So this is driven by several factors. On the one hand side, we have an advancement of quite a number of technologies. Sensors, to mention at first place, a new quality of sensors emerging. On the other side, also new architectures coming up, new processing capabilities that we can put into the devices directly at the source. But at the same time, it's also driven by requirements, in particular also our values that we have looking for privacy protection in the systems. But on the other side, there's also technical requirements driving this lower latency, for instance. So for instance, if we are looking for response time in the system in the millisecond range, the server where this data is being processed cannot be further away than 100 kilometers from the place of the actuation. Otherwise, the latencies will destroy this. And this is not even considering computational time. So what I want to do is also to make the link with what is happening here, especially in our environment in Europe, and the capabilities that we have, they're connected with these capabilities. So you see that on the right-hand side there. There's a lot of good sensor developments and sensor providers in this field. We have quite a strong capability in automation, IoT, making IoT happening, and robotics actuation. And bringing these things together with then tiny AI or the AI capability processing inside these devices, then, as I will show a few examples, will open complete new capabilities. So what it is good for, now I will spend a little bit on the potential out of that, is this will touch every area of our society. And it will touch several sectors across the industries. So starting with examples from transportation, I mean, most popular, of course, the autonomous vehicles, but also smart connected supply chains, where local smartness in these devices will make a difference. A substantial area also in the business development or in potential and need to become more effective, to drive differentiation and also reduce waste in the systems is the second line, all these industrial applications starting from condition monitoring, anomaly detection, but also predictive maintenance, doing some. And this is also where often quite a number of data is being produced, which should be increasingly processed also locally in order to make this efficient in terms of bandwidth, in terms of current consumption for communication, and also the latency requirements that these systems have. And I will not go into the others, but this will, you name it, it goes across the sectors. Healthcare, we have seen several examples already during this event. Agricultural applications and also retail, quite substantial benefit behind these technologies inside here. What I want to show is also, or one aspect that I want to elaborate on is saying we talked a lot about ethical aspects of use of AI, risks that we have to address. And I'm not saying that risks do not exist in this environment, but these are other risks that are dominant here. It's if we do it inside a machine control algorithm, for instance, it's less likely to have ethical implications. Still, of course, we need to make sure that we have a robust application and it's trustworthy, and that we take the uses of this along when doing this, when implementing these things. So I will touch briefly on a few examples here. Some of them are surely well known and quite popular, starting with a smart speaker, with voice controlled. And just winding a few years back, still this was the classical approach. We have the microphone inside there. We have some activity mechanism here, but quite amount of the data, the words, the audio stream will be transported to the cloud, creating all the issues that relate with these kind of systems. All of a sudden, our private information goes into the cloud. It gets processed over there. The processing time and the transmit is quite relevant inside here. And the capabilities to make this an intuitive interaction with this device is quite limited. So what this goes into, when we bring the intelligence into the system, when we even go beyond a single sensor and do the sensor fusion inside the device, we can give this device some sort of contextual awareness. And this creates the interaction with these devices much more intuitive. So we can implement functionality that the stream, for instance, the discussion, it's first of all not just a one single question answer and then stop and a new interaction. We can make a continuous dialogue, because eventually the machine will recognize that there's a follow-up question to the first question, things like this. This can be done by detecting how the human approaches or moves away from the device with new types of sensors, as some example. But we can also make handover mechanisms from one speaker to the next speaker, when we move around in our home. And of course, this is not an application only in private environments. This is also increasingly relevant in industrial environments. Think about maintenance activities where we have the capability to put findings or orders by voice into the system rather than typing into some complex user interfaces. So another advantage of such kind of mechanisms is that it makes the technology more accessible to more people. Because we don't have to adapt to the machine and learn how the machine works and how we have to speak to the machine, that it's reacting as we expected, but the machine more or less will gradually adapt how we expect it to interact naturally. And this brings me into the next area. The clicker is dead. Now it's coming. Expanding on different types of sensors here, and as the title says here, enabling machines to interact with humans as we expected with a natural interaction. And this makes it more accessible, these technologies. There's quite a number of new sensors out there in the market with higher resolution and different arenas. So, and they mimic nearly all the human sensors, looking at quite advanced sensor technologies for the nose. CO2 recently has become quite popular, especially in the pandemic situation, but also any other type of gas, multi-gas sensing and environmental sensing becomes relevant both in industrial but also in societal environments. Also, radar technology offers very good potential for this interactiveness while preserving privacy, replacing cameras. Some of you may know that there's expected to be about 35 billion cameras worldwide in public spaces already. Quite a majority of them is streaming the videos to some servers inside there. So not only is this a huge waste of energy, but also, of course, all the, as we know from video, people are easily identifiable, and this is a concern. Replacing many of these applications with radar, as an example, really solve this and can bring these applications to battery-powered devices even. There's quite a number of these existing use cases, for instance, entrance control, counting people, detecting presence of people, detecting the situation, whether people are standing, moving, etc. All this can be done by radar, and it's quite energy efficient, actually. It can be processed completely locally in the device and provides quite some advantages. But also there's much more capabilities of these sensor technologies. Looking at vital signs, for instance, with radar we can detect the heartbeat, the pressure, the pulse pressure, etc. Gesture and motion detection, opening new possibilities for the interaction, how to control the device, giving signs to the machine. Also, this is some requirement when we have touch-free or contactless interaction, but also other areas like material classification are quite relevant examples here. And we see here just some visualization of some simple demos for this, showing the performance of radar versus classical cameras. So these kind of use cases can be replaced by these technologies and provide some advantage here. Now I would like to switch to another example from an industrial environment, predictive maintenance, condition monitoring and things like this. Tone is still there. Quite relevant as well. There's suspected more than 10 billion of market behind, especially these applications, out of the 150 billion of automation as well. And now I come to the next area. What does it take here to make these things happen and to bring these together? It's a collaborative effort. I already elaborated on the sensors. I will also touch on the processing engines, the inference engines, how we execute these algorithms. But of course, it also very closely links to the capabilities that we have developed here in Europe, being security and connectivity activities like this to bring this together. So very briefly, just for bringing us on the same page, I believe the mechanism is well known here in this event. But when we look at these type of applications, there's two things that I would like to highlight. And one is the validation stream, where specific attention is required, particularly when we bring this into functional safety domain. So make sure that the things work in the environment that they are set in, and not only based on the training data set that they have eventually been trained on. And the second thing is also how to bring it effectively into the devices, into the little devices. Some of them are battery powered, as I already mentioned, making this mapping to there and having the specific hardware in place that can execute this in an energy efficient way. We're not talking about super processing units inside there, but really target hardware that is optimized to the use cases and make this happen. Somehow I have problems with the clicker. So as part of that, there's not one solution that fits all. It is here we are talking really about an environment where we have to optimize the implementation to the specific requirements in the specific field, opposed to some more server-based architectures where we are more aiming for a general purpose type of engine. I have to accelerate a little bit. So what I want to say is also, so we talked about already about cloud and software and data infrastructures. Now I have talked a lot about the sensor and the hardware, but there's even more than this that we need. And this is where it comes to this collaborative effort. We have to also look at the broader ecosystem to bring these capabilities together. And also, of course, talent to bring this in the broad field is a major topic. So, and this is something maybe as a kind of conclusion out of this, saying these capabilities, they build on the capabilities that we have strongly established already. Mechanical engineering, automation, and robotics, very strong presence what we have here. Then there's some differentiating capabilities that well present also on top of that, like functional safety, like security architectures, like common standards as well. And if now we bring this together with the capabilities of the AI, with the new sensor technologies and the capabilities to bring AI in a robust, in a responsible manner into these devices, this can create new levels of differentiation for the individual players, but also for the society and the industry overall. And I'm just mentioning two areas that have probably significant market relevance: autonomous driving, benefiting from new generations of sensors, making these algorithms more effective, catching up in the global race for this, but also collaborative robotics, offering new ways to deal with the challenges of our time, including aging society. So this concludes pretty much the presentation. Thank you very much for your attention.
Thank you very much, Nico. We even have some time for questions.
Oh,
yes.
okay.
So my colleague Nina would have a microphone if someone has a question. I found it very interesting that you made the bridge between industrial uses of embedded AI, but also what it actually can bring for the end user directly, because making that bridge between these two areas of application is, for me, not always so easy, and you made it very well. What do you think, Nico? How far have we already moved to the edge? What do you think? How much potential, or on what well, not on a scale to 1 to 10, but are we there yet? How much potential is there for companies to use, to leverage edge AI?
I would say the potential is clearly massive and significant. Market projections say that somewhere in 2025 will be a crossover point in terms of share cloud-based solutions versus edge-based solutions. As said before, the one will not completely replace the other. I see it more like a continuum, and we have looked to case by case which one makes sense. But I think these here really, the potential really is to combine, make these technologies available, and in many cases bring them in sync with our values that we have. Like the example with a camera-based system operating on a server versus a radar-based system that is completely local and self-sustained, things like this. And this makes it energy efficient, it preserves the privacy. So the potential is huge. It's estimated with the cloud part of that is estimated with at least 100 billion in terms of the components only that go in there, and there's usually a factor in the application then that how this scales up.
So basically it means that technology then can enable us to somehow alleviate some of our concerns, or to match some of our concerns concerning privacy, trustworthiness, etc., by just using a technical solution that actually helps us to achieve or to use AI in the way we want with European
Definitely, yes, this is the one part, but the other part is also, I think it really makes a contribution to the challenges that we have: energy efficiency, sustainability, avoiding waste, things like this. And this is one technology that definitely has a significant impact on that.
Great. Maybe on that, we'll also look at sustainability of AI later on the day on this stage as well, because, of course, very big topic. On the one hand, AI can help to somehow, be more energy efficient, use less resources, but on the other hand, AI is using a lot of energy as well. So quite a balance that needs to be found. So, Nico, thank you very much.
Thank you very much. Thank you.